test questions for water plant C. This is not an all-inclusive list, and it does not keep you from studying. This is just a help. Okay? So, Langmuir index calculation. You're going to have a couple of those, maybe two. Okay? Langmuir index, I don't know if I'm pronouncing that right, Langmuir or whatever, but it's corrosiveness, right? Corrosiveness. 7 is neutral, 14 is scale forming, supersaturated, 0 is corrosive, anything below 7, right? Okay. Alkalinity ions when what's present at a certain pH, so don't forget that. Corrosion is electrochemical a lot of times, if not most of the time, so keep it in mind as you go through this. Your chlorinator is not feeding full volume, okay? Well, that is probably a problem that you need to look up in your troubleshooting, okay? The chlorinator vacuum, why is it used? That safety, right? That way it doesn't have the same issues again and again, okay? Frost on the chlorine line, reliquefaction, right? Keep that in mind, okay? Residual math. You're going to have dosing, possibly a residual question. It's all 1 + 1 = 2. It's nothing complicated. Residual in the system, 0.2 minimum in Florida, so keep it in mind. The taste and odor residual, right? A loss in residual is going to cause possibly a taste and odor issue. The cross connection definition, right? You need to know is connection between a potable source and an unpotable source, or potable, or however you want to pronounce it. All right. MCLs, you're going to have things about THMs, specifically about when it forms in seasons, what seasons it's the most active. Also, how does THMs affect with temperature? Obviously, the formation goes up with temperature. Your MCL for TTHMs, or trihalomethanes, are 0.080. It's in the parts per billion. Don't forget that. 0.080. And lead, 0.015. That's the action limit. Don't forget, lead samples got to sit for 6 hours before you collect them. First draw, no flush. Okay? First draw means it's the only type of sample you do that with. Okay? At least in this purpose. Aeration, THMs after formation, right? Okay, so how do we remove THMs after formation? Aeration, right? They're volatile substances, so keep that in mind. Your MCL for dissolved solids is 500 MgL, okay? Your lime and alum, when combined together, is explosive, right? So we don't want explosions, so we're going to get rid of that. Alrighty. Okay, CO2, safety question. It's corrosive, okay? It's gas. It's corrosive. So keep it in mind. CO2 adding for pH adjustment, it lowers the pH levels, right? Because gas makes pH go down. Sedimentation, coagulation, dosing. Make sure you know that, okay? If it's settling too quickly, you need to know what to do with the dose. Do you need to back the dose off? Do you need to increase it? There's going to be a relation between those two different subjects, so keep it in mind, even though it does not precede each other, right? Sedimentation purpose, to remove suspended matter, right? That's the whole purpose, using gravity and a little bit of time and a little bit of coagulant, and it just goes to the ground, right? Types of lime used in the system, hydrated and quick lime, right? And if you slake lime, it's going to create heat. Don't forget heat. When to add lime, the lime solution, right? So make sure you know that when you're supposed to add lime for softening. What is not part of sampling, and it's setting the lid on a surface. Don't want that, right? You don't want to be contaminating your samples. Solids contact unit, you need to know at least a little bit of subject about that. It combines coagulation, flocculation, filtration. Okay, uses a sludge blanket to adjust the depth of that to adjust how you run it, at least for the purpose of this test. So keep it in mind. Thiosulfate is to neutralize chlorine. Okay, otherwise you have it would continue to form. Disinfection byproducts would. Okay, so keep that in mind. Also with THM samples, no bubbles. Okay, no bubbles at all, and they're quarterly. How is the MCL for total coliform samples or your bacteriological samples? How is it determined? It is determined by population. Remember, it's for an indicator organism. Okay. Alrighty, math, grains per gallon. All right, so in your grains per gallon, you're gonna look at the top of your formula sheet. It's on the top. All right, fairly easy conversion. They're gonna ask you one question probably about that. PSI to feet, foot to PSI. All right, make sure you know those, 0.433, 2.31, however you want to do it, that's the way to do it. It's on the formula sheet, don't forget. Volume math, it's going to ask you about volume. Make sure you know how to do volume, because otherwise you're not going to get any of the detention questions right or anything like that. So make sure you know the 7.48 and the 8.34, which is the pounds. 7.48 is the gallons per cubic feet. All right. Dosing math, make sure you know how to do the Davidson pie chart. You do not need to know how to do it both ways. You can do it one way. You just need to plug the answers in order to get it. Now, it's going to slow you down a little bit, but if you're not good at math, just keep it in mind. Okay? That's why math shouldn't be on the test, because otherwise you can do that. All right. You're going to have a question about usage, gallons usage, 5%, how many pounds would it be, that kind of thing. All right, so just remember. So remember, your dosing math is going to be a lot, so at least 5 questions. Detention math, you're going to have at least 3 questions on detention math. So make sure you get your volume right. Make sure you convert it from MGD to the fully written out number. All right, that's my little hint for you guys. Iron and manganese math. Make sure you know a little bit of that. If you're good at math, you're just going to plug this information in. All right, backwashing of filters, right? Improper mud balls, right? Improper means mud balls. Improper means mud balls, right? Not supposed to bump the filter or anything like that. If you do an improper backwash, you're going to probably get mud balls. Now, if you backwash at an improper rate, you may get cracking and shrinkage, right? Dry, desert type looking cracking, shrinking, okay? Lion King, right? Remember that? Okay, time to backwash if something's broken, okay? If your radar indicator is broken, you can measure the depth of the water. That's all of that your radar indicator is doing, okay? How do you determine your filter performance? Head loss, okay? Activated carbon is added before filtration because you don't want turbidity, okay? PAC, you want to add that before. Filtration purpose, to remove turbidity, right? That's the final kind of step for turbidity. Raw water changes. Make sure you know how to change for those.